Hello everyone, in this video I want to talk to you about how to transform a cubic function, okay, or how to talk about cubic transformations. And this really also applies for all polynomials. Since we're talking about polynomials in our most recent unit, meaning any exponent greater than x squared, x cubed, x to the fourth, x to the fifth, any of those functions can be transformed the same way. And this equation that we're going to talk about today will apply as well. But for cubic transformations more specifically, we're going to be talking about the function x to the third power. That's what it means to have a cubic equation. So let's get into the transformations, to the changes that can be done to the equation, and the stretches, the reflections, the transformations, the shifts, all of that stuff, and get right to it. Alright, so these are the different functions that we have spoken about already before. If you look at this first one right here, we're dealing with the absolute value function, right, where we have the a, h, and k, and if you remember this one, the function looked like the letter v. And we spoke about how to stretch it, how to compress it, how to move it left and right, up and down, those kinds of things. The next one was the quadratic, right? We spoke about quadratics for a good 9 weeks, actually, and we spent a lot of time talking about the compression and all the different properties of quadratics. And for transformation quadratic, we looked at the parent function that was also centered around the origin. Most parent functions, as we discussed in our second unit, are going to be centered around the origin. So if you're looking at these, really we're using the letter a, h, and k for all of our vertex forms of our transformations. So since we're dealing with the cubic function, this is the function that we're going to be working with. F of x equals a x minus h cubed plus k. That's really what we're talking about here as we're moving. Let me see if I can detach this. Just 1 second. All right, well, this is going to be the parent function that we're going to be working with, the a, h, and k, where h and k are the vertex. A is the fact that we're going to be compressing or stretching the function by, and we'll get more into here in a little bit. But this x cubed function really can be used as anything else. We could also write this as any polynomial. So we can have the same a, same vertex, but then we can change it up here as any number you'd like, to the fourth, to the fifth, to any power. So these rules that we're going to be talking about really specify to any polynomial that we're going to be dealing with, but we're going to be focusing specifically on cubic functions, what they look like, how they behave, and how they change centered around the origin. So let's get talking about more about what do they look like. So a cubic function looks like this. I'm going to center it here. I'm going to create a small graph. Right? It's always good to know what you're looking at when you're solving an equation. Equations have a lot of letters and numbers, and it's always a lot easier to understand something when you can see what you're working with versus just manipulating letters and numbers. So the cubic parent function is actually centered around the origin and looks like this. Okay? Now, when we're talking about the a, h, and k of this parent function, right? Let's talk about the function f of x. Equals a Okay, so let's talk about the a, h, and k. All right, the h and k is the part right here that's centered at the origin. This is considered the vertex of our function. Okay, so it's an ordered pair. One thing to know that we've discussed before is when we're dealing with the vertex of the function, is that inside the equation, it'll always be the opposite. Okay? It'll always be the opposite number for h because inside the parentheses. Since we're subtracting a number here, if we move this to the right to like say positive 2 units, if we move it to the right to 2 and we're going to say x minus 2, notice how this minus 2 is already opposite to this positive 2. If we go to negative 2 and we put x minus a negative, this minus and negative changes to plus. So the equation would say x plus 2 when it's on the left, and it would say x minus 2 when it's on the right. Something to consider here in the future. Now, the h and k move the vertex up, down, side to side. The a is what's going to be manipulated, right, based on the compression or the stretch. And if we remember the rules, if a is greater than 1, we're talking about a vertical stretch. Let me make some space here. So we're dealing with a vertical stretch. We're multiplying the function by anything greater than 1. So let's just say that we're multiplying the function times 2 or times 10, right? The numbers are going to get a lot larger, squeezing the function closer to the y-axis. So it's going to make it point higher. And this is really what you can expect when you have a number here in the front that is bigger than 1. You're going to start seeing the equation get really, really close. Let me see if I can. It's just going to squeeze in here when a is greater than 1. If a is between 0 and 1, right, we're talking about now a compression. So usually you're going to see the numbers here as fractions or decimals, something between 0 and 1, like 1/2, 1/3, 1/8, those kinds of things. And at that point, what you're going to see from your function is going to start getting a lot wider. It'll still go through here, but now it's going to get a lot wider, and that's when you can see the compression. Let me change the colors here because I think it's easier to see it in a different tone. So if you see a compression, you can picture the function doing something like this. All right, notice how at the origin, the numbers are getting squeezed for the stretch and flattened out for the compression because it's going to be dealing with a fraction of something between 0 and 1. So these are the different changes that we're going through, right? The rules have been the same. The h is going to move the function side to side. The k is going to move the function up and down because it's controlling the y-axis. And the a is what's making it either vertically stretch or compress, making it narrower or wider, respectively. So let's do a couple of examples. So here we have 1/2 x plus 3 cubed minus 1. We want to describe the effects of the changes. So let's start with the 1/2. So here I know that a equals 1/2. Since a is between 0 and 1, we're going to say that this function is being compressed. So vertically compressed. It's going to get, in essence, wider. Or flatter there at the origin. It's going to get flat. It's going to get wider and pulled out horizontally towards the outsides. Then we talk about, this is the 1/2. Then we want to talk about the plus 3 and the minus 1. Okay, the plus 3 is the h. So since h equals 3, remember, everything inside the parentheses will always be the opposite behavior. So if it's saying plus 3, it really is moving 3 units in the opposite direction, to the left. You're translating the origin 3 units to the left. And then the minus 1 on the outside will do exactly as it says. Because we're subtracting 1, then k is going to do exactly as it says, and we're going to move 1 unit down. So if I were to do like some sort of sketch here, let's see if I can squeeze it here on the side. I'm going to be looking for a function that's going to move 3 units to the left, 1 unit down. So this is going to be the h and k. The origin got moved to this spot, or the center or the vertex of the graph, and then it's going to get compressed, going to get wider. So I'm looking at a function that's wide, and at the same time going through this location. Man, my graph is pretty bad. So it'll go wide, and then it'll go through that point. We'll call that point -3, -1. All right, this is what it would look like if you're dealing with an equation. Now let's talk about if you're given the words, how would you write it going backwards? So here we're giving a description. We want to be able to translate it and talk about the function in general. But before we do that, let's write the general form that we're going to be dealing with. F of x equals a x minus h cubed plus k. I want to identify the letters using the appropriate colors. So for a, I'm going to use the color blue. This cubic function was translated 4 units to the left and 5 units down. It was reflected over the x-axis and vertically stretched by a factor of 3. So reflected over the x-axis and vertically stretched by a factor of 3. That's going to be the effects on A. Anytime that you're reflecting over the x-axis, we're making the sign opposite, so it's going to be negative. And since it's going to be stretched by a factor of 3, we can say this is going to be -3. So let's start with our function. Let's say that our function is going to be f of x equals -3. And we'll write the plus h and k here in a minute. It also says, we'll do this in red, this minus h part and the k. The cubic function was translated 4 units to the left and 5 units down. So to the left means that the function is going to be inside. So we're going to have x minus 4. Now, since we're going to the left, we're usually going to be doing, going to the negatives. So minus a -4 to the left. And then 5 units down means -5 on the k. Now let's interpret some of these symbols. Minus a -4 really means +4. You see how the signs change? Since the function is moving 4 units to the left, subtracting a -4 makes the function inside actually be x plus 4. This is why earlier I said that when you're dealing with inside the parentheses, everything inside parentheses will always be the opposite behavior. 4 units to the left means x plus 4 because of that minus negative. Over here on the right, we have plus -5. Since we're moving the equation 5 units down, we can simply just say -5. And this is it. This is the effects of transformation the function is going to. It's being reflected, so it's being flipped with the negative. It's going to get stretched by 3. It's going to move 4 units to the left and 5 units down. So you can do this graphically, you can do this with words, you can go back and forth, different notations. As long as you understand the effects of A, H, and K and how it changes the picture, how it moves it, how it transforms it, you're able to go from words to the equations and vice versa. I hope this has helped. Please let me know if you have any questions below. Please click the like button, and if you haven't already, smash that subscribe button. And as always, we'll calculate.